Okay. So this is our group project, and we have our picture of the Mount Rainier here, and this is the east-west line, the north-south line here, and yeah, so now we're gonna continue with that. All right. Do we want to both share our screens, or?
I don't really care. I'm happy to share my screen if you want.
Okay. Because I feel like he said that he wants everyone. Yeah. All right. So now we're supposed to do a screen capture of the elevation profile. How do we look at the elevation profile?
Okay, I think I learned this. Let me see if I can remember.
Record a tour, add a place mark, add a polygon.
Screen share. Yeah, the entire screen is fine. Share. Okay.
There you go.
I have my line, and I saved it in my places. So over on the side, in places, I just did an NS for my soft line. And then I think if I right click on that, I can just show elevation profile.
Oh.
Ta-da!
Look at it. Okay. Cool. Let me try and figure that out.
And if you want me to go through that again, I can go through the steps again.
Okay, hold on a second. There we go. So I can't find it. It disappeared. So it was over on this side, right?
Yeah. So right click on whichever path you want to look at.
Okay.
If you right click on the name, it should show up a list of all these different tools.
Oh, show elevation profile.
Yeah.
Whoa. Okay. All right.
I want to go back to my top view. And I don't know how to do
What'd you say?
Mine's looking at it from an angle, and I want to look at it from the top, and I don't know how to change that back.
Okay. I don't know how to take a screenshot. That's the fun part. Let's see. How do I... Do you know how to take a screenshot?
I don't.
Okay, I think if you go to the snipping tool. Okay, so you can follow this. That's cool. All right. There's the snipping. Ah, come back. New. Okay. I think I took a screenshot. Save as. Okay, there's one, and then I'm gonna do one of the, because I think we need one of each, right? Or is it just the east-west?
I can only see one for the east-west right now.
Okay. Okay. So it says, once you've taken a screen capture of the elevation profile of the east-west transect and use that to create an illustration that resembles the kind architecture you would expect for this kind of volcano, be sure to annotate and label your illustration. So I'm not quite sure what we're supposed to be doing with this exactly. Okay, so we're supposed to do. Do you get what we're doing here with the create an illustration?
Let me see.
No. Ah.
I guess 1.1. It just looks like it's a conic, a shield cone.
I can't understand what you're saying. Sorry, you're breaking up.
Oh, sorry. Based on our elevation, it looks like it's just a shield volcano.
Okay.
Would you agree with that?
I think so. Like, when it comes to the volcanoes, I'm not that great at understanding it all, but
Same.
yeah, I would guess that that's what it would be. Let's see. Let me. Let's see. Yeah, I would say. What kind of volcano did you say you thought it was again?
I said shield.
Yeah. Let's see. Yeah. It's the only. When you look at the picture of one of them too, it kind of looks like that. Let's see, what's the exact. Yeah. Okay, so shield volcano. Okay. No, what I wanted. All right. So then we have the screen capture of the elevation. But oh, there's a snapshot view. I don't know what that means. Maybe you can take a snapshot on this thing. But I don't feel like it did anything when I clicked on it. Okay. Terrain. Global awareness gallery, roads, voyager borders, labeled places, photos. I don't know, I'm not seeing anything about illustration. I don't understand what it's asking. Ugh. Okay. See if I can. There more. All right. Okay. Um, that didn't answer my question. Okay. This should be that. All right. So far, we have our lines and then the elevation here. And we've come up that it's a shield mount or volcano. And then we did the screen capture of the elevation profile. What do we do for the illustration? That's what I don't understand.
So I think as far as doing illustration, we can open it in Paint for something like that and just draw all over the thing that we captured.
Okay.
What I don't understand is the architecture. What do they mean by architecture?
Let's see, let me look in the book and see if I can find something. There's nothing in the book about architecture that I can find.
And my copy of the book is digital.
Yeah, that's how mine is too.
It's not my favorite, but it means I can search a word. And when I search for architecture, nothing came up.
Yeah, that's what I've been trying to search too. Okay, well maybe can we move on to maybe the next one and come back to that one?
Sure.
Okay, so it says compare the elevation profiles for both transects created above. Which side of the mountain has the lowest elevation? Okay, so now we do need to look at the north south. So or wait. Yeah. Okay. So if I look at the north-south one, show elevation profile. Okay, so it says the max elevation for the north-south line here, at least for my line.
Do you want max or min?
Well, I was just looking at all of them. So the max is the 14,364 feet, and then the minimum is the 6,824. At least that's what mine is showing. And then you have your average here. So then if we look at the east-west, here, let me write those down. And then I can, yeah, because we also have to submit a document too with all of our stuff on it, I guess.
Yeah, I copied all the stuff to a Word doc, and I've just been kind of, I mean, we haven't had that many answers to type in, but I've just been typing the things we find them.
Perfect. Okay. So did you get a snapshot or screenshot of the north-south line?
Yeah.
In there? Okay, perfect. All right, I'm just going to write down 6, 8, 2, 4, 2, 8, 9, and 14, 6, 4, Okay, so then if we look at the east-west line, it looks like the east-west line, for me at least, has a lower elevation and a higher elevation at 14. Yeah, by like 20 feet. It's a little bit higher, but which side of the mountain has the lowest elevation?
I don't know where the mountain ends and begins.
Yeah, that's the thing is it depends on how far my lines went because this side is short and this side is lower. But I feel like this side of the mountain has a lower elevation because it's a little bit more. Do you see how this line is a little bit lower altogether than this one is over here? So I think that the right side, the at least the west side here. Let's see. Now I'm gonna look at the north-south and see what we have. Let's see, show elevation profile. It could even be this one here, because look at how that dips there. On the north side. What would you say?
I see. I don't know if it goes in north or the west, but I'd say it's definitely one of those two.
Yeah.
And I wasn't super careful about following the lowest elevation.
Yeah, me either. I think, just looking at this one, I would say that, but then it also on this one, it says that when you look at the results, it's technically this side that has the lowest, the west side. Okay, I think the west side has the lowest elevation technically. I guess this one has like the biggest drop. But like I'm not really sure. I guess this is the elevation gain / loss here. I wonder what is it on the other one because we're looking at that one. Let's see. Yeah. I guess yeah. I don't know. Like I'm not a geologist. I don't understand this stuff very well. So we're looking at this line here. Okay. Yeah, I would say that the north side has the lowest elevation. I guess. In elevation gain and loss, it has the lowest, and then the west side has the lowest altogether. At least on mine. I don't know about yours. When you're looking at it, what you see.
Mine has the north side having the lowest elevation. But like I
What'd you
said,
say? I don't know if it's the headphones or what, but I can't understand you. Sorry.
No, it's mine. I'm sorry about that. Mine has the north side having the lowest elevation.
Okay.
But again, I wasn't super careful, so it
Then
could
let's go
be a
with,
different path.
yeah, let's go with the north side then. That's what you said, right? The north side on yours? Then let's go with that. All right. Okay. So it says for the next part, what consequences could possibly result on the side with the lowest elevation as a result of that topography? Take into consideration what type of volcano this is and what potential hazards exist. So we decided that it's a shield volcano. I guess maybe it isn't a shield volcano, because doesn't a shield volcano have to be like an island?
I'm not certain about that.
So as I'm looking at it, it sounds like it needs to be. I'm going to watch the video on the volcano types here and see.
Types of volcanoes. There are several different kinds of volcanoes. Generally, differences in magma composition and style of eruption result in different kinds of volcanic peaks. Cinder cones are the smallest kind of volcano. They are steep, cone-shaped peaks built up entirely of pyroclastics. The kind of magma associated with cinder cones varies, but it is often basaltic. Cinder cones may erupt only once or twice before becoming extinct, and few are higher than about 450 meters or 1,500 feet. Shield volcanoes are broad, low-lying peaks that are built up from layer upon layer of solidified fluid lava flows. Basaltic lava tends to be very fluid.
I wonder.
So most shield volcanoes are made up of basalt. Shield volcanoes
I feel like this might be a
very
cinder
high,
cone
but they are
volcano.
never steep-sided. The Hawaiian Islands consist of a chain of large basaltic
Because it doesn't look like it's a volcano that's like
the Hawaiian hotspot.
super low.
Composite volcanoes are large, symmetrical, cone-shaped volcanoes. They commonly form from intermediate composition lavas, such as andesite, and contain a moderate amount of silica. Such volcanoes will experience both explosive eruptions of pyroclastics and quiet eruptions of relatively fluid lava. Composite volcanoes build up with layers of pyroclastics ejected by explosive eruptions, alternating with lava flows from non-explosive eruptions. The pyroclastics tend to produce the steep slopes, while the lava flows hold this loose material together. Dome complexes or plug dome volcanoes form from very thick or viscous lavas, such as high silica rhyolite. Lava
So I wonder.
from the vent, and the dome
I think it might be a
mostly
cinder
from below.
cone volcano.
Because these
When it explains what it is.
Cone-shaped peaks built up entirely of pyroclastics. The kind of magma associated with cinder cones
I don't know.
varies.
I don't
I was
understand.
looking as it's going over it, and it said that the composite volcanoes are very symmetrical. So I thought maybe composite, but then again, I haven't looked at all the volcanoes and seen how symmetrical
I
they
still
are.
can't understand you. I'm sorry.
Oh, if I was home, I'd give you a good set of headphones, but I'm not.
What?
If I was at home, I would get a different set of headphones, but I'm not there.
Oh, that's fine. Yeah. Okay, then we'll just keep it at a shield volcano.
Well, the videos that composite volcanoes are very symmetrical.
Mm-hmm.
And as we cut this in half, both directions looked pretty similar.
Yeah.
Could just Google it.
Kind of see what they think. Okay. Let's see. Here. Well, it says that it's a stratovolcano, but that's not one of the types that the book talks about.
It's the same. Composite is also known as stratovolcano.
Okay. Perfect. So it's a composite volcano?
I guess so.
Okay. Okay. So it's a composite volcano or a stratovolcano. Perfect. And then so because of what kind of volcano it is, what could possibly result on the side with the lowest elevation as a result of that topography? Take into consideration what type of volcano this is and what potential hazards exist. Okay. So some things that could impact it would be the temperature of the lava, how often it's going to erupt and stuff like that. They're called composite because they consist of both pyroclastic material and lava flows. So on the side with the lowest amount of elevation, what could affect it is if there's lava flow and it's down that mountainside, it would flow a lot faster down the mountainside, I would think.
Yeah.
I don't know if that's true. I'm like,
It makes sense. Also, if there was a bunch of rain, so flash flooding type of a situation, or if there was landslides, I feel like more stuff would fall to right there.
yeah. So landslides, flash flood, kind of rain, right? Those are some of the consequences, or what could affect it really badly. And then, I mean, yeah, especially because it's a composite volcano. Well, and it says that there's also the pyroclastic flows. So that's like when it is a flow of hot gases infused with the ash and large lava fragments. So that could be a really detrimental on the lowest elevation because it's going to all come down that way and prevent things from happening. Okay. Are there any other things that you can think of?
No.
Okay. All right. And then in question 1.1, you predicted the kind of volcano this would be. Based on that answer, what rock types might you find in this area? List all that might apply. Okay, well, we originally predicted that it would be a shield volcano, but then as we did some more research and found out more information, we decided that it was a composite volcano. So what kind of rock types would we find? In composite volcanoes. I'm not quite sure what type of rocks we would find.
Basaltic lavas.
There's what?
It has basaltic lavas and silica-rich magma. So, what kind of rocks have basaltic lava and?
Well, it actually says, when I'm looking in the book, it says that it produced andesite or rhyolite lavas, which is apparently more vicious than basaltic lava. I don't know what the difference is exactly with that and why it's that way, but so let's see what kind of rocks. Oh, okay. So it says that the andesite is a fine-grained rock that is formed when the magma erupts on the surface and it's crystallized quickly. So that's one of the types of rocks that we would find.
And what was that called again?
It's called andesite, Andesite.
Cool.
Because it's a silica-rich lava, typically is what comes from composite volcanoes, and that's why it gives it the steeper sides and the angles. And then the other one, something. Hold on, let me look it up. Okay, let's see. Okay, so it says the rhyolite is an igneous volcanic rock. So it would be an igneous kind of rock that we would find with the rhyolite. And rhyolite is spelled Rhyolite. All right. Okay. And then I'm not sure. I mean, we could even look at so from what I'm seeing is it's like the silica rich kind of rocks. And so it just lists that it produces andesite or rhyolite, which is the igneous rock. I don't know if you found any other ones. Ah, weird noise. I don't know what's going on.
If we want to include basalt, it says many composite cones
Okay.
emit various amounts of basalt, basaltic
Okay.
lava.
Alrighty. All right. So now that we have a list of the rock types, it says take a close look at the mountain and its surroundings. What other geological features do you notice in this area? I mean, there are some lakes. That they have here, and other mountain like formations leading up to.
Yeah, some lakes, some rivers.
There are quite a few lakes, and then you're seeing all the drainage that was happening. Zoom out here. Let's see. That's pretty far off, but they have like a glacier island here. Right there. Not seeing much of any like options. I'm curious. Let's see. Let's look at roads. Do they have roads? Okay. All right. Yeah, seeing lots of the drainage, and so you're seeing some of the snow too that's falling. And and there's this mountain range here. Kind of little. You have the Cowlitz chimneys. Go Island Mountain. So yeah, you just have lots of little mountains, I feel like, off the surrounding it, you know? I'm just finding all these different and then lakes. Um, all right, so we've got different mountains and lakes. And rivers. And they have things like the Glacier Island, which is like a little mountain off of it. And a few others. Are you seeing anything else that you'd like to add?
Not really.
Okay. Sounds good. And then backing out a ways from Mount Rainier, answer the following. Is this volcano close to any tectonic plate boundaries? How far away is it? Let's see. I'm not seeing. There's terrain. Let's get to those photos there. Are you seeing if it's close to any?
Yeah.
Those are the borders. I'm not quite sure how to tell where the plates are. Let's see. Let's see. So when I'm looking at a picture of where the plates are at, I can zoom in on this picture. Let's see. There's the Pacific plate right along the outside of like California, and it shapes all the way on the outside of the west side of the mountain. So let's see.
Can you see my map?
Oh, yes. Hold on. Let me just make it bigger. Okay. Yeah. I'm talking, so now it's making yours go away. There we go.
So for my lab, I had to download a dynamic earthing.
Okay.
And it has the plate boundaries and labels.
Okay.
What does it say about the boundary? So this one, the plate is a smaller plate, but you can see that blue line is a fault line. And then this orange and green lines are also fault lines.
Okay. Yeah, so that would probably be the closest one that it's near. Oh, yeah. Okay, so it's close to the. It was the Juan de Fuca. Is that what it's called? Okay.
Oh no! There's the name.
Okay. Cool. Okay, so that's the plates and the fault lines that it's close to there. And then the last part. It says what kind of tectonic boundary is it relative to North America?
So the blue line is subduction zone.
Okay. That was the question. What type of tectonic boundary? You want a subduction zone?
And the red line that is next to it, that's an oceanic spreading ridge.
Okay, so what does that exactly mean?
It means that the ocean is spreading further apart instead of coming closer together.
Okay. So would that mean that if it's spreading further apart, then this blue side would be going towards, right, the American continent here, while the other is going more out into the ocean?
Yeah.
Okay. So you have both moving away to and from, so they're not colliding with each other, but they're going their separate ways. Okay. And then so wait, what kind of line did you say the orange and green line is?
Just a moment.
It was a
There's the key.
it's not showing up.
Oh, that's weird.
It's like a white box. Let's see. I'll see if I can maybe figure it out on mine.
So the red one is spreading ridge, and the green
Spreading ridge.
the green is an oceanic transform fault.
Oceanic transform fault. Okay. And then the orange one you said was what again? Sorry. Or red. I guess it's red.
Oceanic spreading ridge.
Oh, both the red and green are that?
The green is a transform fault, and the red is spreading ridge.
Okay. Thank you. Perfect. All right. And then it says, do you think there is any relationship between the tectonic setting and the occurrence of Mount Rainier? If you do, explain that relationship.
I don't know on that one.
Do you think there... I mean, it might have something to do with it, but I don't think it has too much to do with it because the plates aren't like colliding. Does that make sense?
Yeah.
So it's not like right where the plates are at, they're near plates. And so it might have some effect to it where it's kind of pushing it up a little bit, but I don't think that it's affecting it enough to make that. I don't know, do you agree with that? I'm like, I don't really know.
It's as good as anything I could come up with.
Okay. Relationship, it's pretty small. It's not enough to affect it too much, I feel like. Okay, and then I think this is the last question. I'm not sure. It's gonna be okay. So it says, are there any other noticeable volcanoes in the area within a few hundred miles? What similarities or differences do you notice about them? There's Cascade Range, but I don't know if that's a volcano.
So, a few hundred miles. If you go out. Can you see my map?
Let me pull up the. Okay, whoa.
That line is 200 miles.
Okay.
So there's lots of volcanoes.
Yeah. Okay, so let's look at maybe one or two of them and see kind of what similarities of like the two closer ones are.
A lot of them are stratovolcanoes.
Okay, so stratovolcanoes, which means they're all kind of forming the same way.
Not all of them are, but a lot of them are.
Okay. Okay. And let's see what's somewhere about St. Helens here. Not what I wanted. Okay.
you can tell where all the volcanoes are because they're little white spots of snow.
Yeah. Well, and it's interesting because it's also they're kind of in a line. You see this? They kind of follow. They're not like scattered everywhere. It's just like right here. I think that's interesting. That's cool. All right. Is there any other similarities or cool things that you've noticed about the mountains?
No. Like you said, they're all in a line.
I think it's really interesting that they're all kind of the same volcano. Not all of them are, but that they formed, you know? Probably has something to do with the location and being closer to the coastal edge. All right. Cool. Well, I technically have to go, but we still need to figure out what they meant about how to create an illustration and what that it resembles the kind of architecture.
I kind of wonder if that just means I'm going to get all of these terms wrong, so I'm not even going to try. But how the top is formed and the side, the walls, because it was saying that this type of volcano, it's really steep and then shallows out at the bottom. I think we might just have to draw in and label that stuff.
Okay, so maybe later today I can look at that because we're just talking about doing it on. Hold on, let's stop showing that. There we go. There we go. So maybe we can do that separate from the video, and I can maybe go in and try and look at it and finish that up on the illustration and send it to you, and you can put it in the document.
Okay, or we can each just do that and put it in our own documents, whichever one.
Okay, that's fine.
I don't know what your day is looking like. I don't want you to feel extra pressure to try and get that.
No worries. Yeah, no, that should be fine. I can do that, and then yeah.
And then can you just make sure you send me a link for this video?
Yeah, I will do that.
All right. Thank
Perfect.
you so much.
Thank you. Okay.
Have a good day. Bye.
You too. Bye.